What if I told you that the most important machine inside BYD's billion-dollar empire isn't a battery, a robot, or even an electric motor? It's an engine that most people never see. An engine built inside massive factories hidden across China, where raw metal enters one side of the building and a finished hybrid powertrain emerges from the other. And that engine may be the reason BYD is quietly changing the future of transportation, while much of the world is still watching Tesla. For years, the global conversation around cars seemed simple. Electric vehicles were the future. Companies raced to build bigger batteries, longer ranges, and faster charging systems. Tesla became the face of that revolution. But while the spotlight remained fixed on pure electric vehicles, something unexpected was happening thousands of miles away. BYD was building a completely different strategy, one that many industry experts initially underestimated at first glance. BYD looked like another EV manufacturer competing for market share. It sold electric cars, expanded production, and opened new factories. Nothing unusual. But hidden behind those headlines was a decision that would eventually separate the company from nearly every major competitor in the industry. Instead of choosing between gasoline and electricity, BYD decided to master both. That decision sounds simple today. It wasn't. Most car companies rely on a vast network of suppliers. One company makes batteries. Another supplies engines. A different manufacturer produces transmissions. Components travel across countries before finally meeting on an assembly line. It is a system that has worked for decades, but it also creates dependence. Delays, shortages, rising costs, and quality issues can appear at any point. BYD looked at that model and asked a different question. What if we built everything ourselves? At the time, few people understood how ambitious that idea really was. Building batteries is difficult. Building engines is difficult. Building electric motors, transmissions, software systems, and vehicle platforms is difficult. Doing all of them under one roof sounds almost impossible. Yet that is exactly what BYD began creating, and the scale of that vision only becomes clear when you step inside the factories. The first thing visitors notice isn't the size, it's the movement. Machines never seem to stop. Conveyor systems glide silently across massive production halls. Robotic arms move with perfect timing. Sparks flash from automated welding stations. Thousands of components travel through carefully choreographed routes that resemble something closer to an advanced technology lab than a traditional car factory. But even that doesn't reveal the full story, because the most important work isn't happening where people expect. Deep inside these facilities, engineers focus on a machine called the Xiaoyun engine. To most drivers, it looks like an ordinary 1.5-liter gasoline engine. Small, compact, nothing particularly dramatic. Yet this engine became the heart of a system that would challenge assumptions about what a hybrid vehicle could be, and the reason why won't become obvious until much later. Before understanding the engine, you have to understand where it's born. Across China, BYD operates an expanding network of manufacturing bases. Cities like Shenzhen, Changsha, and Guangzhou have become critical pieces of a giant industrial puzzle. Each facility serves a different purpose. Some focus on research. Others specialize in vehicle assembly. Some produce batteries. Others build POWERT together. They function like a single giant machine. The Guangzhou facility in particular feels almost unreal in scale. Workers often describe it as a city disguised as a factory. Production lines stretch farther than the eye can comfortably follow. Vehicles move through assembly stages continuously, day and night, without pause. Every few moments, another car emerges, then another. Then another. Numbers become difficult to comprehend. Millions of vehicles per year, hundreds of thousands of an output so large that it rivals the manufacturing capacity of entire automotive groups. But the real surprise isn't how many vehicles BYD builds, it's how many parts it refuses to buy from anyone else, while competitors depend on external suppliers. BYD produces batteries, motors, controllers, electronic systems, and hybrid components internally. Even many of the materials feeding those production lines originate from within BYD's broader ecosystem. That level of control creates something powerful. Speed. When shortages disrupt global supply chains, companies dependent on outside suppliers often struggle. Production slows. Costs rise. Launch schedules slip. BYD faces those same challenges, but it responds differently because much of the supply chain already belongs to them, and that advantage would become incredibly important once demand exploded. But demand wasn't always guaranteed. In fact, one of the biggest questions facing BYD was whether drivers would even want hybrid vehicles in an era obsessed with fully electric cars. At first, many believed hybrids were simply a temporary bridge, a stepping stone on the way to complete electrification. Then, something unexpected happened. Consumers began choosing hybrids in enormous numbers, not because they feared electric cars, because they wanted flexibility. And this is where the story starts to get uncomfortable for many of BYD's competitors. That the company wasn't selling a compromise, it was selling a solution. Vehicle that could feel electric during daily driving while eliminating one of the biggest concerns associated with EV ownership: range anxiety. Suddenly, the strategy that seemed conservative started looking surprisingly forward-thinking, and hidden inside that shift was the engine that made everything possible. The same engine quietly rolling off assembly lines every single day inside factories most people will never see. But understanding why it works requires going even deeper inside the manufacturing process itself. To understand why BYD's hybrid system became such a powerful weapon, you have to follow the journey of a single engine from the moment it exists only as raw metal. The process begins long before a car reaches an assembly line. Huge shipments of aluminum, steel, and specialized alloys arrive at the factory every day. At first, they look like ordinary industrial materials. But within hours, those materials begin transforming into one of the most important components in BYD's entire business strategy. Inside casting facilities, metal is heated until it becomes liquid. The glowing material is poured into molds that define the basic shape of the engine block. Nearby, forging machines apply immense pressure to strengthen critical components. The noise is constant. Sparks fly. Machines move with a rhythm that never seems to stop. What emerges is still far from an engine. It is only the beginning. Rough blocks then travel to machining centers, where some of the most precise work takes place. Computer-controlled tools remove microscopic amounts of material from each surface. Cylinders are bored. Mounting points are shaped. Internal passages are created. The tolerances are incredibly small. A tiny imperfection that is invisible to the human eye can eventually affect performance, efficiency, or reliability. And BYD has little room for mistakes, because this engine is expected to perform a job very different from what traditional engines have done for decades. Most gasoline engines spend their lives directly powering the wheels. This one often doesn't. That distinction may sound minor, but it changes everything. As components move through assembly stations, robots and technicians begin bringing the engine together. Pistons slide into cylinders. Crankshafts find their place. Timing systems are installed. Cooling channels are checked repeatedly. The machine takes shape, yet something important is still missing: the electric side. And that's where the story becomes far more interesting. While the engine is being assembled, another team is building something called the Electric Hybrid System, or EHS. This is the part most drivers never think about, and it's arguably the most important part of the entire vehicle. Inside separate production areas, powerful electric motors are constructed with extraordinary precision. Copper windings are installed. Magnets are positioned. Cooling systems are integrated. Electronics are calibrated. Eventually, these components meet the engine, not as competitors, as partners. For over a century, the automotive world treated gasoline engines as the star of the show. Electric motors were secondary. Assistants, helpers, BYD flipped that relationship upside down. The electric motor became the primary source of motion. The engine became support, and that single shift changed the driving experience completely. Most people don't realize this when they first sit inside a BYD hybrid. They simply notice that the car feels different, quieter, smoother, responsive. Almost like an EV. But this only matters once you see what happens when the battery begins running low dot in a traditional electric vehicle. Battery charge determines everything. As the percentage drops, drivers start thinking about charging stations, travel plans, and remaining distance. BYD wanted to remove that mental burden entirely. So instead of forcing the engine to constantly drive the vehicle, engineers designed a system where the engine could operate under conditions it prefers most, not maximum power, maximum efficiency. When battery levels fall, the engine quietly comes to life. In many situations, it doesn't directly push the wheels forward. Instead, it generates electricity. That electricity either powers the motor or replenishes the battery. The driver barely notices. The transition feels almost invisible, and that invisibility is exactly the point.